All right. Okay. How to do kick-ass software development. So Stefan always said that, already said that DV13, my hashtag is kick-ass. If you want to tweet, Sven Peters, my Twitter handle. So for those actually who have seen the movie Kick-Ass, Kick-Ass is just an ordinary guy who actually who's just putting on a costume, and then he's kicking ass. He's fighting against criminalists. And for those who have seen the first scene of when he fights, he got really beaten up the first time. But so here's the thing: he stood up again, and he did a second fight, and all of a sudden, Hit Girl joined, and Big Daddy joined, and they really became a kick-ass crew. And so this is actually my talk in a condensed way. So for software development, it means we should stay up. If something bothers us, we should fix that. We should also go. And sure, we will fail. But we have to fix this. So this is about kick-ass software development. But I want to start with setting some expectations actually here. So who's actually here to expect to see some kick-ass code, some awesome, great kick-ass code here? Is there somebody? All right. Well, for those who are here, this is the only code you will see. Sorry, there is no code. There will be a lot of code in Brian Gert's talk about Lambda, but here there will be no kick-ass code. Another question, who's here to learn a new methodology? The new kick-ass methodology, the new Scrum, the new Kanban, now we kick-ass methodology. Who's here to learn that? Let me tell you this. There is no kick-ass manifesto. Atlassian has not written any kick-ass manifesto, and at the end, you will not get certified. You will not be a certified kick-ass software developer, and we will earn money on that. No. So actually, who's just here to kick some ass? Yay! Awesome. This is your talk. Right. Good choice. Good choice. And actually, this is me wearing the mask, but I decided against the mask wearing it here at DevBox because it's really warm under that mask. The gloves are already warm, so I got a really sweaty hand with the gloves. So, how do we do actually kick-ass software development? How do we do that? How do we achieve kick-ass software development? 2 words: use Java. Thank you and goodbye. Sorry. So, actually, the programming language is, of course, not so important. You can kick ass with Ruby, you can kick ass with C#, you can kick ass with Groovy, you can kick ass with PHP. I'm not so sure about that. Are PHP programmers here in the room? Sorry for you guys. You may leave too. No, I'm just kidding. My last PHP project is 10 years ago, so I don't know anything about PHP right now. So, but actually, I wanna make the developers more awesome. I want to make them more productive, and that's my thing. And my name is Sven. I'm working for Atlassian. We're doing software tools. We're from Australia. I'm from Germany. So if you think this talk kicks ass, you can tweet me. If you think this talk doesn't kick ass at all, you can also tweet me. No problem. So, but I wanna make programmers productive, and I've done that also before I worked for Atlassian. So I'm an old Java developer, and then I became team lead, and I want to make my team awesome and want them to kick ass. So, but what do we want to achieve in software development? So here's a few random things I come up with. So I want to have better software that the functionality is better, and the software itself, the code is better quality, and really a product that people love. I want better software. That's what I want to achieve. I want to have less overhead. I don't want to spend that many times in meetings and answering emails. I want to code. I want to write kick-ass code. And then I want faster development. I want to have my features delivered faster to my customers. They should use my feature. I've just programmed them. They should use my feature, and I want to make them as fast, awesome as I can get. And of course, I hope this also leads to a happy customer. I want happy customers. And all of this makes us happy developers, and that's what we want to achieve. So if you would have asked me 5 years ago, Sven, what do you think? How do we achieve that? I would have to say, okay, good. Be agile. Agile is the solution for everything. So if we're being agile, we have short iterations, so we value the customer more. We can deliver our software. We can show our software actually faster to the customer. Get fast feedback. Agile is great. I told you 5 years ago, I would have said that. So actually, what's the state of Agile in the year 2013? I think we hear more and more people bashing on Agile. Actually, here also at DevOps, I was here 2 years ago, where Martin Verboek did his famous talk, The Diabolic Developer. And he was saying something like, compiles equals ship it. Great. No, it's not. I mean, does we value the customers with that? No, not at all. I mean, we are delivering software and the customer can test it. That's not valuing the customer at all. But you know, I'm a software nerd, and a little voice inside me says, "Awesome, great, yeah, that is fun." All the guys from the Dark Manifesto of Agile Software Development, who are replacing some words like individuals and interactions and not process and tools. All the guys from this league here, the programmer motherfucker guys. Yeah, so, and that doesn't replace just words in the Agile Manifesto. They actually replaced the sentences in Agile Manifesto and asked, what's the real value of that? It's programming, motherfucker. Really, we should. So, is the question really, so is Agile dead? Are we waiting for the next big thing? Do we expect something new, something awesome like Agile? Is it dead? Should we look out for the next big thing? Well, so here's the thing. Every methodology, every technology goes through a curve like this, like the Gartner hype curve. And at the beginning, all thought leaders said, hey, awesome. We should use that. And then the early adopters said, yeah, it really helps us. It's great. And then a lot of people are adopting it, and they find out, oh, it's maybe good, but it doesn't solve all our problems. Really. So I think we're at the downside, realizing that Agile doesn't solve all our problems. Actually, it makes sometimes more problems because it makes things more transparent. What is on the other side a good thing? So what should we do? What is the next thing? So actually, we should wait for the next smart people. We need some more smart people that tells us how to do. We're looking for the next guru. No, we're not, because really, stop following the next guru. Don't follow the next guru when Uncle Bob comes and says, software craftsmanship, this is the next big thing. Yeah, Uncle Bob, we follow you into the light. Great, we're doing all now software craftsmanship. No, you should look at your own software development and kick ass. This is it. So, I've been coming around and talking to a lot of teams, and I've actually seen a lot of legacy teams. So don't be confused with legacy software and legacy teams. Not every team that does legacy software is a legacy team. Legacy teams, in my point of view, are teams that they're really hard to change. So it's like legacy software. If you change one guy, you never happen what changed with the rest of the team. So you don't know that, and it's really hard to change. And these legacy teams, they actually may think that, oh, adding process helps. I actually have worked for legacy teams where my boss said, okay, good, we had made this mistake, so we add a process that this won't happen again. Yeah, they really think that that this helps. Also, it was just a small bug, but anyway. And then they think changing stuff is too complicated. you know, we have this web framework and we cannot change that. We have to live with it now until the software dies or whatever. They say that changing stuff is too complicated. They want to change, they don't want to change themselves, and they don't want to change their software. And they say old decisions still apply. There are some old decisions. We have decided for Ant as the build system 10 years ago. We had to have this risk matrix, and we look at it and it was the best thing, and they really think that still applies. Well, I tell these legacy teams, or if you have a friend that's working for a legacy team, please tell him, hey, come on, let's improve. Let's look what we can fix here. Maybe you cannot fix the web framework, but maybe you can fix something else. So let's improve and kick ass again. Some legacy teams may say, I don't give a damn, but we can't fix them at all. So we cannot fix the whole world. So that's up to them. So I've come up here with 4 ass-kicking topics, where it's delivering kick-ass software. So deliver kick-ass software out to the people. One kick-ass team work together in one team. Kick-ass collaboration, how we collaborate better together, and kick-ass automation. And these are 4 random things I took from Atlassian where we really sucked at Atlassian, and we tried to kick ass again. And the first thing is deliver kick-ass software. So, kick-ass software. What is kick-ass software? What is it? It's just a term here. So, kick-ass software for me is if my customer looks like this here. Maybe not exactly like this, but if he smiles like this, using my software, if he goes in the office in the morning using my software and he smiles like this, yay, I'm happy now to use your software. And if he looks like this, well, I'm pretty sure I'm doing kick-ass software here. So how do we actually know that we built the right thing? We want to build the right thing. So how do we know that we really built the right thing? Does anybody know the Microsoft kin here? 1, 2, 3, 4. Okay, good, yeah. So here's the story. I didn't know the Microsoft kin either. I just Googled after Microsoft software disaster, and this one came up. So, and I read the story, and so Microsoft was trying to do a cool mobile phone. So a mobile phone for the young generation, the Facebook generation, the Twitter generation. They could just take a photo and send it up to Facebook, Twitter, Foursquare, whatever. And they brought out this phone, this Microsoft kin phone, and they actually bought a company, and then they had a big marketing campaign and things like that. So they found out after they launched the phone that nobody wants to buy it. Nobody bought it. I mean, just a few people bought it. But here's the good thing what Microsoft did. They removed it from the shelves after 40 days, so they didn't try to fix it. They found out it's not fixable, so we remove it. Good job. But they lost $1 billion for that. So they spent $1 billion on developing it. So actually, how do we know that we built the right thing before we build the right thing? We don't want to build the right thing and then find out like Microsoft. So how do we know that we built the right thing before we built the right thing? And IBM did that. They did so in Atlassian we have one sentence for that, and this is fake it till you make it. And you can go so far with faking your software. And IBM did that. They actually had this idea that they make a speech-to-text software. So what they actually did with the software, so they had a microphone, they did this experiment looking how people are reacting. They had this microphone, they had a screen, inviting people to talk into the microphone, and magically there was what they said was appearing on the screen. Cool stuff. But actually, IBM didn't develop any software for that. They were faking the whole experience. So they had a guy who could type very, very fast and was listening to the thing, and the people who were talking were just seeing it. But actually, IBM found out that this was not a good thing. So they had to use something. You cannot say backspace, delete, or and you get it's really hard to speak for the whole day. So you cannot speak in the evening anymore because you have spoken the whole day. So they actually, and this was actually decades ago. It was decades ago where they tried to do that. And Sorry, I was just confused. So actually, they didn't develop the software. They didn't come up with they didn't develop the software because it was not a good idea. But actually, one step before that, you can start faking things, and we are doing that at Atlassian. So if our designers they have to come up with a cool design for a user story, they sit together and they make prototypes, but not prototypes like we're doing prototypes as developers. They're doing paper prototypes, and that's very, very cheap. You have just some glue, scissor, a pen, and paper. And then you're building your prototype. So they go into this session, this paper prototype session, and maybe they have 16 ideas. And from the 16 ideas, they're trying it out on paper, and they find out that 14 of these ideas doesn't really flow. And the good thing is, you're not connected to this thing. So you could just script it together, throw it in the garbage bin, and try the next idea. So if you're doing a prototype with HTML or Swing or JavaFX these days, you already have a connection to that. So you spend maybe 2-3 hours, and you really want to make that, and you can say, okay, I can change this here and can change this here. No, you just throw it away with paper prototypes. And the paper prototypes looks exactly like this. So exactly like this. So this is a video that I found on YouTube. So it's actually totally faking the experience. Totally fake everything. So, and it's as I said, very, very cheap. So now we have running software. We have running software out there, all of us. And how do we actually know what we should improve in our software that's out there, that is used by our customers day in, day out? What fields should we make better? Where can we make the customer more awesome? How do we find that out? Well, we can find that out through feedback. We can gather feedback for our things. So we're looking actually for feedback, but not just feedback. We want to generate a kick-ass feedback experience that people really gives us feedback. What they want to get fixed in our software. So how do we generate a kick-ass feedback experience? So I went to London, to Heathrow, to the airport, and I found this one here, this thing. And it's a feedback machine. So you go through the security, and then they ask you, how is your security experience? And you can push the buttons there. So it was very, very easy to find. There were 4 terminals just behind the security, very, very easy. And then it's very, very simple. Just 4 buttons. I could press good, bad, in between. And if you want to make more detailed things, there are also paper to fill out if you want to give detailed feedback. But this is very fast, and it's very fast to submit. You submit it and you go. It's really done in a few seconds. So that's good. So we at Atlassian, we actually our Jira Agile team, they wanted to make, formerly known as Greenhopper, they wanted to make a new board. And they had this idea of the new board, and they wanted to have as much feedback as they could get for this board. So what they did is they wanted to make a kick-ass feedback experience. So what they did is they put this button, this get feedback button, just in the header. So everybody could see it. Everybody that installed the software and used the software could see it, and it could give us feedback directly. And if you click on that button, you get an in-app window. So it's in the application. You don't have to move to another web page. It's just in the application, and it's very, very simple to fill out. Just a few fields are required, and you can fill it out. And it's very fast to submit. And if you press the submit button, you're back where you started. You're back where you started. So very, very fast. So as I said, easy to find, simple, fast to submit. This is how it goes. And actually, our Jira Agile team, they got 4 times as much feedback as they had before, when there was a link just down at the page where the feedback button is normally. So they got 4 times as much feedback. Isn't that great? Well, kind of, because actually we want to protect our developers from that whole feedback. I mean, we're developers, we are good at coding, and we are paid for good coding, so we don't want to spend our time for feedback. So we should protect our developer for getting that feedback. Actually, Google, the Gmail team has coined a term for that, and it's called the SHT umbrella. And so these numbers are a little bit old. It's a Gmail team, 100 developers, probably more right now, and 425 million users. So you could do easily the math on that. You got 4.25 million users for one developer. He will get nothing done if he has to read all through feedback. So they have this shit umbrella where the product marketing, the product managers take care of everything. They gather all the feedback, and then they prioritize that, remove duplicates, and all the stuff. So great, isn't it? Oh, that's so awesome. We can just code, motherfucker. That's cool. But actually, we are not Gmail at Atlassian. We don't have 425 million developers. We have, users. We have maybe a few million users and 350 developers. So actually at Atlassian, we're saying everyone has to go onto the front line. Everyone has to know what bugs our customers. What's the problem with the software? Every developer has to know that. And we send them to conferences, so you could speak at conferences to them. The customer could speak at conferences to them. And we really collect feedback through our ticketing system. So we actually want to close the feedback loop and get personal. And this is what the Jira Agile team did with all the feedback. They actually met for 45 minutes each day because they wanted to make this board awesome. And they listened to all the feedback and they answered directly. And the thing is, if a developer answers a support ticket or a feature request directly, and you let him down, so you say, no, we're not developing it, people will better understand that because they actually have reached the right person. They know they have reached the right person there. So this person experience. Actually, a colleague of mine, we are developing Fisheye, and we recently said on our Jira instance, we're not going to develop a visual source safe for Fisheye. We're not going to do that. This was a ticket. It was, I don't know, 8 years old or 7 years old, and we finally closed it, said, no, we're not going to do it. And the first feedback we got was, thank you for being so transparent. Wow, cool. But this is not the only thing we do. We're also sending our developers on support. So each developer at Atlassian has to spend 1 week each year on first level support, so they really know what bugs our customers. They really have to answer calls, maybe debug together with the support people. So also the support people learn things from our developers. And if they come back to development and says, oh, they have this problem all the time, well, they have a workaround. Our support has a workaround, but we can fix that very, very easily. So it's actually a win-win here. So think about that. Care about your customers and have an effective feedback loop. Close your feedback loop and generate a kick-ass feedback experience. All right, the next thing I want to talk about is working together as one kick-ass team. And the support example was just working together as one kick-ass team. The support understands the developer better and the developer understands the support better. That's awesome, that's great. Let's have a look at something else, what we face in software development. Well, we have developers and we have testers. And yeah, they have different roles and different responsibilities. And we all know that's a bad thing if you throw our task or our software just over the wall and let it test by the testers. That's a bad thing. We shouldn't do that. But on the other hand, they are specialists. The testers are specialists. They can test very, very good. So, but it leads actually also to bottlenecks where we have in front of a big release and we're throwing everything over the wall and the QA is testing and the developers are just waiting and then they come back and say, oh, there's a bug and we fix it fast and throw it again over the wall. So this is not working. And the most important thing here is we lose accountability. We are not responsible anymore for the quality. It's the quality assurance. It's the quality assurance department that is responsible for the quality. If there's a bug, they haven't tested it good enough. So that's not working. So at Atlassian, we think we're very engineering driven, and we actually thought we can solve everything through automated testing. That's so awesome. We had a test coverage from nearly 100%. That's so cool. Everything was automated. Cool. But then actually our customers, they found bugs, and we said, we can't be, so we hired a tester, and he said, yeah, maybe you should also manual test your software. Okay, good. So how many testers do we need? Yeah, a lot. So that doesn't scale for us. At Atlassian, we have a program called Developer on Test, or we call it DOT. And at Atlassian, developers also have to test the software. So it's the developers. So I'm taking a task from somebody else and test that. So you might say now, the developers are doing now all the work, and the testers are just sitting there drinking pina colada. Not exactly. So it's not that. So we found out that developers are as good as testers when testing easy stuff. So we divide our task in easy to test and hard to test. That's our testers are doing that. And the testers are testing the hard to test things, and developers are testing the easy to test things. And we find as much bugs as the testers in the easy to test things. And QA, quality assurance, doesn't mean quality assurance at Atlassian. QA, it's called quality assistance, because the testers are assisting the developers. They're helping them to become better testers. They're finding new test software. They're actually helping with automating tests, all this stuff. So they assisting the developers to become better testers. So here are actually 6 tips for kick-ass dotting, how we come up with kick-ass dotting. And the first 3 tips are basic dotting, and then I have 3 other tips, which is advanced dotting. The first thing is training. I already said that. We send our developers on training. So theoretical, how to test things. They spend 1 week how to think like a tester, things like that. And then if they come back from training, we are pairing together. Our testers are pairing together with the developers. So they're sitting together, testing things, and the developer is testing, and the tester is giving tips how to test, and said, if I would be you, I would test more into that direction. So they're pairing together, and the developer is learning from the tester that way. And then I presented that last year already. We're doing blitz test, which is just 2 hours, which is not only dotting, it's not only developer on test, but it's also marketing on test, or finance on test, where we invite actually the whole company to test new milestone releases, new features of our software. And our testers are saying, okay, you test this feature, you test this feature, and you're just trying to break the whole stuff. So everybody at Atlassian is testing. So this is our basic dotting. Now we come to advanced dotting. I told you that our testers are doing the complicated stuff. That's no longer true. We are also there just writing test recipes. So they're taking the user story and saying, if I would test this, I would go into that steps. So please test this, developers. These are test recipes. And then we're making split sessions, which is the opposite of pairing, where we sit together, where we test the same thing. A tester is testing the same thing, and the developer is testing the same thing, and we separate them. They're sitting in different rooms, and then at the end, after 1 hour testing, they come together and comparing the results and learn from each other. And then we're doing something very experimental right now we call Bug Hunter, where there's one guy in a team for 1 week who is the bug hunter, and he hunts after bugs. So he goes to the done column and takes whatever is ready and try to find a bug in there. Well, what does that make with the team experience? I don't know yet. I will come back next year and tell you that. But that's what we're doing right now. So we are trying to change things, trying to make a kick-ass team out of our development team and our test team, to work that they can work together. Because quality is actually everybody's responsibility at Atlassian. It's also my responsibility as an ambassador, traveling around and using Confluence. If I find a bug in Confluence, we're dogfooding, so we're trying our own software before we release it to our customers. If I find a bug, it's my responsibility to tell the Confluence team to fix that. And so how does dotting went at Atlassian? So we implemented dotting, and we went from a 36% error ratio, so we had 36% errors in our tasks, to 9%. So really, you can see the accountability has come up, has gone up with that. Okay, another one kick-ass team. If we talk about developers, we have to work with designers. Are we doing our own design? I mean, we are cool in doing design, and if somebody asks us to do something, we can also make software. I mean, we can put in check boxes and things like that. So if I make my test generation data software, I can do that, and it will look something like this, I think, which is pretty nice, isn't it? I like that. It's a lot of possibilities I can check. Okay, maybe it's not that nice design. Maybe we should add some colors. Yeah, right. So let's add some colors. What? What? Oh, somebody asked us to do a cool web page. Yeah, we can do that. Looks nice, doesn't it? So we actually asked the questions. Why should we have designers? Because customers came up and said, "Oh, your design is not very good." We didn't have really designers. We had some skilled programmers with design skills, and that was pretty good. So we hired the first designer, saying, "Okay, good. Maybe we need one designer. Have a look at our awesome software." And the first thing he did was look at drop-down menus in our products, so in Jira, Confluence, and Fisheye, Crucible, and all our products. So he had a look at drop-down menus, and he found, yeah, there are some good-looking drop-down menus, but there are so many of them, and they are all different. So he looked at all drop-down menus we ever created in our software, and that's really a lot. And they are all different implementation, different drop-down menus. Cool. So why should we us? Easy answer. Because we suck. No, no, that's actually not true. We had some good developers with good design skills. But how do we scale designers actually? And you may get the answer right now. What we do at Atlassian, we use developers because we had this skilled developers with design skills at Atlassian. So we use developers for that, and we are also sending them to training and things like that. They were actually good designers. Actually, they just need some guidance. They needed some guidance to not create another drop-down menu. So we came up with design guidelines, and that helped us a lot. So our design team, after fixing all these things that were bad in Jira and Confluence, they said, okay, we're coming up now with design guidelines. They sat together for 2 weeks in a meeting room and came up with the design guidelines. And we didn't want to make it too complicated. Everybody should use it. So the developer should just take a control or change a control very, very easily. So just a few rules. We want to make it simple. Then they made this rapid prototype tool where we can use kind of wiki markup to build our interface, to make a rapid prototype, to show that to the designers. So the developers are going to the designers say, is that something you think we can use, or is it good? And actually, this all leads to faster dev speed, faster development. Everybody is allowed at Atlassian to do design and to try to change things. So this leads to kick-ass dev speed. As I said, we are sending also our skilled developers. We're sending them to design workshops, that they become better designers, that they become hubs in teams for doing design. We can go to them and say, hey, I need a new button, and I'm a developer, but I'm not really skilled with design skills, so can you please help me? So at Atlassian, developers are doing design. Cool stuff, good. But should we look at the other way? So if we get something from designers, it's a Photoshop image or something file, and we have to put that into software. This is friction. This is really friction. So we really have to hand it over, translate that in HTML. So this is friction, and we want to remove friction. We want to work together as one kick-ass team and move fast forward. So you get it, not only developers are designers at Atlassian, also designers are developers. So they design in code. They are allowed to change code. They are allowed to change the CSS file, which is a little bit scary for designers sometimes, that they are coding. And I'm not saying that every designer at Atlassian is happy with that. But I think half of them, they are happy with that, changing the code directly. Okay, good. So all of this, and I don't want to start with DevOps here. That's another story. So all of this is removing friction between departments, remove barriers between departments. We should know what the other teams are doing, and we should understand what the other teams are doing. So work together from the idea to the operation actually as one kick-ass team. This is kick-ass software development. Okay, next thing I want to talk about is kick-ass collaboration. Yeah, so I remember the good old times when I was the lonesome cowboy coder. I was doing my pet project, and I'm still doing that, and that's fun. You don't have merge conflicts, but because you're the only one committing code, that's great. The quality is awesome of your code because you're the only committer, and you know every line of the code base, so you can change things easily. You understand the whole code base. That was fun. The good old times, wasn't it? Actually, the trouble started actually when I had to work together with a team. We had to collaborate. There were merge conflicts. The quality is different. And actually, I don't know what this importer thing package is doing. I have no idea. I've never worked on it. It's just this one developer who's always working on it. I have no idea what this is. So we have to collaborate on code. We have to work together somehow. This is hard, especially for developers. So let's have let's see some processes. So we need some processes to work together. So let's have a look at some processes in traffic. If you look at this traffic junction, it's somewhere in the States, I don't know, with traffic lights. So the cars that going this way, they stop currently because the light is red, and the other are driving, and then it's the other way around, and then we drive, and then we have to stop at the next traffic light. So it's stop and go. If you compare that to traffic in India, it's look like in India, it's look like this. Well, wow, there's no stopping at all. It's flowing, really. It's really flowing, and I've watched this video a few times, and I can't see any rules in there. It's just, but it's working. It's they come forward, and it's great. It's good. All right, so. But that this comparison is, of course, if I compare that to software development and rules and processes in software development, it's of course because we all know traffic rules should protect us from accidents. We don't want to have accidents, and we don't want to die. And I'm pretty sure that more people die in accidents in India than in the States. So, but if we compare that to development rules, we always have to think, if we add some process here, does that really help us? It protects us from making mistakes, yeah. But on the other hand, it drives us down to dev speed. If we're stopping and have to wait for something, it drives us. It goes down. The dev speed is going down. So, and I worked for a company who said, okay, we need to put everything in the processes. So we need also the programmers to have a programming process, and it looks like this. No, that's actually not true. But we did something like this. We have to write down in Visio our programming process. We should keep it simple at Atlassian. So we keep it simple at Atlassian. It's just these things. It's branch, pull, merge. That's our programming process we have. So we are actually using Git and Mercurial, and we're using actually a branch for every task. Not every user story, not every epic. We're doing it for every task, every small task, and actually branches that way have short lives at Atlassian. So an average of 2 days, and then you merge back. You don't get that many merge conflicts if you do that frequently, or do that often, and it's an easy workflow. Well, that's not the right workflow. Of course, we need to have some quality assurance here a little bit. We want to have good code quality, so we're using pull requests for that. So every time we want to merge, we ask people, hey, what do you think about these changes? So we don't merge. Pull request works like this is how it will look like if we merge now. So why should we discuss actually code changes? So let's do a game show experiment here. We have these 4 game show candidates, Andy, Julie, Steve, and Lynn, and we asked them the question. So why do you want to discuss your code changes? Somebody wants to press? Julie, I want better quality. Yeah, I already said that. We get better quality when we discuss code changes. That's good. Somebody else wants to press a button here? Lynn, I want to learn. And this is so true, and this is the most important thing why we want to discuss code changes. We want to learn. We want to know what this importer class is doing. Then we can change that too. Or we want to learn from other programmers. That's a great answer. Thank you, Lynn. Andy, do you want to press a button? Andy, come on. I want to feel better. And this is also true. You're feeling so much better. You're not the only one responsible for the code. It's also, everybody has seen the code changes. So if the server goes down, everybody has seen that, so we are responsible for that, even though we should be all responsible for that. But this really makes myself feel better if somebody else has read my code. Steve, come on, say something. I want to blame people. Of course not. That's not what we want to do with code reviews, with discussing code changes, with doing pull requests. We should have a nice language, talking nice to each other, also in pull requests. So, but here's the thing: we have fast approvals. So we need approval for the pull request. If everybody agreed to it, we merge. And we want to do that fast, so we invite maybe 5 people for a pull request. And if 2 people are okay with the changes, we are allowed to merge. So we want to move forward fast. We don't want to wait for everybody. So said that is that developers are thinking often about code, but actually the world is not just about code, it's about collaboration. So how do we communicate actually effectively? So at Atlassian, we like co-located teams. So we have a team in Sydney, in San Francisco, in Gdansk, and in Vietnam. So these are our development teams, and they have to collaborate on something. So we love co-located teams because we think in this team, the collaboration is way better. So if we're sitting together, we can better collaborate on things. But actually, the truth is that's not always possible. We know that. I mean, we got cool people and they want to move on, they want to move with their family, and we don't want to lose them, so we keep them, and somehow we have to communicate with them. So they are still working for Atlassian, and we have to communicate with them. That's the reality. Even though we like co-located teams, that's actually the reality. And then we acquire companies like SourceTree, and they are 2 developers working on a canal island, and we have to communicate with them too. So, and the other thing is, where actually do you work best? Where's the best place for you to work? Is it in the office, or is it in the coffee bar next door, or is it on your couch at home? So here's my answer. It depends. I can collaborate good in the office. I can talk to people. That's great. But if I really want to hack on something, I really want to concentrate on something, the coffee bar or the couch, it's a way better place for that. All these places now, how do we connect them very effectively? And there's one good old technology out there, and we should use that more often, and it's called emails. Great, emails are great. I love emails. Well, look at the advantages with emails. They work offline. I can write emails on planes. I have an offline client. Great, they work offline. They work one-to-many. I can reach a lot of people with one email. I can have a lot of people as in the receiver list. Then they work asynchronous. I don't have to answer directly. I can wait 2-3 hours to answer. That's good. That's great. And I can add people to the conversation. I can forward my email and CC people that they are informed too. Great. And actually, we love emails at Atlassian. That's great. You might think that now. Are you crazy, Sven? We hate emails. My inbox in the morning looks like this. It's way too much email. So we should avoid emails as much as possible. So here's the thing. Emails are very bad for conversations. I mean, the force and back conversations with email, we know that. That's not working. We get lots of spam in the inbox, and we have to sort that out. People are discussing things. They are often too long. They really write novels in emails, and in emails always needs an action. I have to delete it. I have to put it to a different folder. I have to answer it, whatever. So avoid emails as much as possible. So at Atlassian, we're using actually chat very heavily. So who's using chat here at work? That's 80-90%. Cool, that's good. So at Atlassian, we have a lot of chat rooms. So we're working with a lot of chat rooms, and we, for example, have the Confluence developer chat room where the Confluence developer are hanging out. They discuss about stack traces. They discuss about code changes. Actually, we have an integration with our build server, so we can see when the build is read as a chat message, and we can see when somebody did a pull request. So we have an integration in our Git repository manager. So that's great. That's where the Confluence developers hang out. And then the design team has, of course, also their own chat room where they discuss about mockups, discuss about designs. And then we have something like a enterprise discussion chat room where our enterprise team is hanging out. And if I get a question from a big company, I can't answer that easily. I go just to the chat room, raise the questions, and the enterprise experts are sitting there. They are answering the questions. I can get it back to the customer immediately. And then the good thing is I can close the room again. I can leave the room and don't get all the discussions that are going on there, because that's actually too much for me if I had to listen to all the discussions there. And then we have something called a beer drinker chat room and cat lover chat room. I don't know what's going on there, but anyway. So the good thing is you just subscribe to the discussions in order you need to kick ass. So chat is actually great for remote conversations. Of course, I can contact somebody in San Francisco directly. I can contact somebody in Sydney directly. Great for remote conversations. But what we also found out, it's great for local conversations. So we also, if we're sitting in the same room, we are chatting. Because some people, they don't want to get disturbed. They are in the zone right now, and they don't want to get disturbed, so they turn off their chat client, get into the zone, and they don't want to be disturbed by conversations. So, and when this guy is ready again for collaborating, he looks up into the chat room. He's coming out of the zone. He looks up in this chat room, watch the discussion that has been happening. Awesome, great. So he has the whole history and can jump into the discussion. And this is also what makes it good if you work in different time zones. People are going to bed in Sydney, discussing about things, and they're going to bed, and then San Francisco wakes up, and they can look at the conversation, and they can understand why some decisions has been made, they have been made. So they are reading all the discussions, they can agree, they can disagree, they can jump into the conversations. Awesome. And the good thing is also with chat, you can pull people in the conversations just by using the mention annotation. Just mention somebody and you can pull him in. And I know that Thomas has done that already, so let's pull in Thomas into the conversation. That's great. But the truth is, we should choose our tools wisely. We should choose our tools wisely. Sometimes email is good, sometimes chat is good. So if I communicate externally, I cannot use chat. Unfortunately, I have to use email. So, and then there's this thing where we collaborated and we need to kick ass. So we had this problem in Sydney that we grew a lot, so we had to move to another building, or we had to expand to another building, and there was a big street between the two buildings, and it was very dangerous to cross the building, to cross the street, to collaborate, to go over to the other side and talk to the other developers. So even though there was a traffic light just 100 meters away, nobody was just using that. Everybody was just crossing the street. And we don't want to have our developers to die, obviously. And so we thought we need to come up with something great, something awesome, something good to help to come over this problem. And somebody watched a movie and he saw this movie here, and it's Stargate. So we thought, okay, let's build a portal. Awesome, we can go through the portal, be on the other side. Awesome. Well, maybe we're still working on that, but what we actually did is we built this here. It's very easy. It's just a television, it's a camera, a Mac Mini, and you can go there. You say, okay, let's meet through chat, let's meet at the portal, and you can go there and communicate. And it feels like you're really talking to the person directly. Not exactly like this, but it's way better than just doing a Skype call. So we actually had this portal in Sydney. Now we moved to another office where we all sitting together, so we removed that portal again. But this was the problem, and we tried to kick ass. We tried to make it better. This is the thing. So remove collaboration friction. Easy workflow means faster development. Think about your workflow and develop faster. Okay, good. The last thing I want to talk about is kick-ass automation. So here's the thing. What we do as software developers, day in, day out, we are helping people by automating their stuff. we're doing software for other people, and we're automating their stuff so they can get more productive. They are being more productive. That's good. But how much time do we spend as software developers each week to automate our stuff, to make our processes better? Well, not that much, actually, as I can say for me. So if I talk about automation, who's doing continuous integration? I think about continuous integration. There. Okay, leave your hand up, please. Who's doing kick-ass continuous integration? 1, 2, 3, a few. Yeah, good. At Atlassian, so here's what our builds look like. They were actually our builds took too long. They were actually way too complicated. We had way too complicated builds. Nobody was really finding out what's happening there. They were unstable. We had unstable builds, and then they really missed the concept. We didn't have a concept. We put in task after task, and so actually, in short words, our builds really sucked. They were bad, really, and it took us 1.5 hours to make a full Jira build with automated test. It's awful. So, but what we want to achieve actually is we want to fail fast. We want to be fast we want to know when we introduce the bug, we want to know that actually the best thing would be I check in my code and I know immediately the light goes red, the light goes green, I have to fix something so everything is good. That's what I want to achieve. Okay, we're not there yet. We're trying hard, but we're not there yet. So, but if our build goes into a queue and then take 1 hour, and then we know that our build phase, I'm already at task B, I'm already at the new task, and I have to go back if my build failed. I have to go back to task A and fix that, and then it's really context switching here. I don't want to do that. So we are actually down now to a Jira build takes us 10 minutes, which is still too long, I think, but it's okay right now. You can grab a cup of coffee in the kitchen and start then, if the build is green, with task B. So here are actually 4 things how we tamed our monster builds. And I wouldn't say we kicked ass again. We were still trying to improve things here. And the first one is a little bit an embarrassing one, but I have to say that. So we found out that passing the artifact helped us a lot. So we built our artifact. So we make the compile step, we build everything, and then we check it into Artifactory or Nexus and grab it from there. Every other task that is doing in our build system grabs it from there. And that actually helped us a lot. We went down here from 1 hour 6 minutes to 36 minutes. So that's just by parsing the artifact. It's a little bit embarrassing. But anyway, it's working. It helped us. And then we saw, okay, why not throwing more hardware at things? So we have all this test, and unit tests should run parallel. There should be an isolated test, not depending on each other. They don't have to run frequently. We can run parallel. So we actually bought more EC2 instances in the cloud and let our build run there. So we parallelized our tests. And we looked at our build strategy. So before we had a build pipeline where we said, okay, we're building, we're doing the tests, the performance tests, the whatever unit, UI tests, blah, 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 the platform test, and then we say the build is green, the build is red. But actually that took too long, and we couldn't make the performance test or the platform test faster. It's just the dependency, or we tried to make it faster, and we did it a little bit faster, but still took us too long. So actually, we're doing that now in layers, in steps. So we're doing the building and the unit and UI tests immediately when somebody checks the code in. It takes us 10 minutes in the Jira example. On every check-in, we're doing that, so we get fast feedback for that. And we find 90% of all our bugs we introduced are catched here. Then every hour, we're doing platform tests, and maybe every day, we're doing our performance tests. So we test in layers, and if we find something in the platform test, yeah, we have to go back, but it's just in the 10%. So this is our build strategy. We looked at our build strategy, changed it. And then look at your statistics. Look at what takes long, what doesn't take long. Be a freaking data porn. And look at that. For example, here you could split this test. You see it's taking way too long, so split this test into 2 tests and getting faster builds. So faster builds actually means less switching tasks. We are less task switching. That's good. You want to see more automation awesomeness? Yeah, I'm trying to give you some more automation awesomeness, what we do. So our testers, they actually saw this pattern here, that we have flaky tests. So you know all these flaky tests, right? Where you build, it fails, you press build again, it succeeds. Okay, everything is fine, yeah, great. But there's something in there, that's a flaky test, something is in there. So what our flaky test detector does is he detects the flaky test, see, oh, it's a flaky test. So I put that test into quarantine, it's not executed anymore. And then I raise automatically a JIRA issue. So next time that the build is run, this test is not it's not executed. So this is our flaky test detector. And wallboards, you should collect so much data, automate everything, and show everything on the wallboard. Is a fast feedback tool that you get fast feedback. Do everything with wallboards. We have plenty of wallboards at Atlassian that's showing us actual data from our iteration and how our builds and code is doing. And then we're doing something we call Freud Bot. It's also some pet project that somebody's doing at Atlassian, where it's a static code analysis for pull requests. So somebody's doing a pull request, and then this Freud Bot kicks in and looking at the code and making a static code analysis and finds out, for example, that, oh, there's this magic number and we should replace it with a constant. So this is our Freud Bot. All right, so we are software developers, and we should actually use our skills to automate things. Just spend a few hours a week to try to make your processes, your automation process better. All right, and then we also have something fun, things like we do this 24-hour hackathons where we say, okay, we have this release button. So if we release the software, we have a BlackBerry Pi there, and then we just push the button, and then the whole release process kicks in, and we can say, really, we want to release Jira now, and we press the physical button. That's fun. So these were my 4 ass-kicking topics I want to discuss with you. So it's delivering kick-ass software, work together as one kick-ass team, from the idea to the operation. Think about that. Kick-ass collaboration, collaborate together. Kick-ass automation. Don't leave now. There's a very important message you will miss. Anyway. So here's the thing. These things are just random things. Just random things I picked from Atlassian. So I could have picked 5 or 4 other random things where we really sucked at Atlassian, and we saw that. And we try to kick ass again. So think about your kick-ass values. What do you want to achieve in your software development? So here's just mine. So I want to, of course, have kick-ass customer, kick-ass team. I want to move forward fast, kick-ass dev speed, kick-ass quality, and it should scale. But so, for example, we found out recently that we delivered last year doubles that much features that we delivered the year before. So we really had improved our dev speed at Atlassian. But we actually found out that also more support tickets were raised. So the quality went down. So we are thinking about, okay, good, maybe we shouldn't go so fast anymore and look more at quality. So maybe these are now our kick-ass values that we want to achieve. At the beginning of the talk, I raised this question, actually. Is Agile dead? And I said, no. All these things I just presented, they are Agile. We are adapting. We are looking at what sucks, and we fix things. So this is really Agile. But our founder, Scott Farquhar, he always says, be excellent in everything you do. Everything you do. It's like running a triathlon. You want to win a triathlon. You're good at running. You suck at swimming or biking. You should improve also your swimming and biking skills. Otherwise, you will never win a triathlon. This is the thing. You should be excellent in everything you do. Everything that you do, you should try to be excellent. Try to move forward. You might say now that, yeah, if I'm coming back now on Monday to work and I present my manager all this awesome stuff I heard at DevOps, they may say no. But the truth is, managers are humans too. These all things that also our managers want. They want to have kick-ass quality. They want to have kick-ass customers. They want to have kick-ass dev speed. So they are humans too. You can talk to them, really. And I agree, some managers are easier to persuade and some are maybe a little bit harder to persuade. I agree with that, maybe. Okay, good. But also what we're doing at Atlassian is we're sharing everything. We're blogging internally about everything, so the whole company gets it. So the whole company is seeing that you're trying things. Also, if you failed, the whole company is saying, okay, they tried this, they failed, we don't have to do that, or even, well, we have an idea how to make it better, so we're trying it again and blogging about it again. And this really, all the spreading this kick-ass stuff is about building a kick-ass culture. It doesn't solve anything if you're just trying to fix everything. Everyone in the team, in the company should be aware that if they see something that sucks, that they raise a flag and say, okay, we should do something about that. This is awful. We should do something about that. This is the kick-ass culture. So I started the story with talking, this talk was talking about kick-ass and these are the pictures from the kick-ass movie when he got beaten up in his first fight. He really got cut by a knife, driven over by a car. But he stood up. He stood up again and did a second fight and a third fight and really kicked ass afterwards. So we won't fix things if we're sitting behind the screen all day long. So step out of your comfort zone. I know it's nice sitting behind the screen, but we should step out of our comfort zone, trying to talk to the testers, trying to be more awesome. We want to be more awesome. And at Atlassian, every team actually has a name. So we have the Muppet team, the A team, and of course we also have a kick-ass team. And the kick-ass team has one poster on the door. So if they leave the room in the evening, they actually see that here. Did you kick ass today? They ask themselves this question: did I kick ass today? And I want you, if you leave in the evening, ask yourself the question: did you kick ass today? Did I kick ass today? Thank you very much. Thanks for your attention.